Hi, Doctor. We are Group 2. Our group member have Chair Shemin, Naziru, Munira, Nazira, and me, Eng Ini. Now we will start our group presentation.
Based on our question 2 data, we decide how winter explanation smoothing alpha, beta, gamma is more suitable for our data. It's because whole winter explanation smoothing is used for data that show both trends and seasonality. It is a 3 parameters model that is explanations of whole models. The whole winters method needs 4 equations with an additional equation that adjusts the models for the seasonal component, which is the exponentially smooth series, the seasonality estimate, the trends estimate, and the winter's forecast and period into the future.
I'm Munir Atira, who would like to continue my part, which is observation. Based on a graph, it shows the comparison between the sales and the hot winter forecast for retail sales in bookstore on quarterly basis for once every 3 years from 1992 to 2006. We can see that the situation for sales and winter forecast is up and down and also follow each other from 1992 to 2006. For example, sales data and hot winter data in December 1998 decreased and increased together until 1999. In September 2003, the second last quarter of 2003, the sales were more than the winter forecast. At December 2000, the winter forecast is more than the sales shown in the graph. In other words, data patterns are trendy and seasonal. Therefore, hot winter exponential smoothing can be considered as the most suitable prediction method for this data pattern. That's all from me. I will pass the next part to my friend. Thank you.
For discussion, the results show data on the bookstore retail sale from 1992 to 2006. Starting with the first seasonal value, we divide the first original data by the first 4 original data to get the beginning value. The level is calculated by dividing the original data in the 5th cell by the first corresponding seasonal value. Then, multiplying the difference between the first level value and the 4th original data with the first seasonal value, the trend is calculated. The whole winter is then the sum of the level and the trend value multiplied by the seasonal value. By subtracting the forecast data from the original data, the error value is calculated. The overall sale for the first quarter of 1992, which began in January, February and March, total sale is 1,863 ringgit. The overall sale for the quarter 2 in 1992, which began in April, May and June, total sale is 1,663 ringgit. And the third quarter of 1992, we start with July, August and September with total sale of 2,351 ringgit. Finally, during the fourth quarter of 1992, we continue from October, November and December with total sale of 2,351 ringgit. The sales statistic then continue until the year 2005. From existing sale volume, we can estimate the sale volume in the following quarter of the year. Therefore, we use whole winter method as of one many time series prediction method which can be used for forecasting. Exponential smoothing, developed by Whole Winter, is the second extension of the fundamental smoothing model and is used for data with both trend and seasonality. It's a 3-parameter model that Whole Winter model extension. The Whole Winter approach requires 4 equations plus a seasonal adjustment equation, which use the solver parameter to get the after the solver of value for alpha, beta, gamma and RMSE.
The level of smoothing constants alpha is 0.8 and the smoothing constant for seasonal estimate beta 0.62 and smoothing constant for trend estimate gamma is 0.4 are employed in the equation for hot winter method. We utilize the formula of show to compute the externality smooth series. Meanwhile, the formula we have stated was used to calculate the trend estimate, and we we also use it to calculate the seasonal value. The formula have shown there was employed to compute the whole winter forecast value. Besides, we also predict the forecast data for Q1, which is January, February and March 2006 is 4,366.84. For Q2 in April, May and June 2006 is 3,393.88. And for the third quarter for July, August and September 2006 is for 5,141.35. And lastly, for Q4, which is October, November and December 2006 is 4,564.54. Lastly, we need to find out the value of RMSE, and the value is 350.90. To get the best solution, we utilize the solver to minimize the RMSE value and optimize the value of alpha, beta and gamma. We find that the reduced alpha value is 0.48, which is from 0.80 to 0.32. Next, we also find that the value is beta increase is 0.38, which is from 0.62 to 1. We have found that it is the reduced gamma value is by 0.24, which is from 0.40 to 0.16. And for the value RMSE, it was found that value decreased by 196.37 from 350.30 to 153.93. The value of RMSE is 153.93 is the best forecasting parameter for this data.
Hi, my name is Ng Ini. Now, I'd like to present the conclusion. Our group have decided to use hot winter exponential smoothing to calculate this problem. Hot winter exponential smoothing is a formula for forecasting time series data that exhibit both trend and seasonal variation. We have learned how to use the Microsoft Excel to calculate levels, trends, seasonal, winter forecast, and errors using the specific formula. To find the optimal solution, we need to use the solver to reduce the RMSE and optimize the alpha, beta, and gamma values. This solution is straightforward to construct and comprehend, which is advantageous for our need. After this group assignment, we were able to examine and interpret the result. That's all for our group. Thank you.